Hello everyone, this is Miss Graham, and today we are going to be looking at lesson 22.1, similar right triangles. So go ahead and pull out pages 303 to 307. Let's start off with our learning targets. We are going to find ratios of side lengths in similar right triangles. And given an acute angle of a right triangle, we're going to identify the opposite leg and the adjacent leg length. Go ahead and skip 2 pages to page 305. So on page 305, what we're going to do is we are going to try to compare different right triangles with each other and see if we can notice a pattern on leg lengths as well as different hypotenuses. So let's go ahead and start looking at this. So we have this situation where Trisha was trying to incorporate a right triangle into different logos that she designs. So Trisha becomes aware of the relationship that exists between the measures of acute angles and the ratios of the lengths of the sides of each right triangle. We're going to use the grids below to draw right triangles that have a longer vertical leg of L units and a shorter horizontal leg of S units. They already have our first triangle drawn for us, as we can see right here. Now we can see that if we look at the longer leg length, we can see it has a measure of 8, like we said, and the shorter leg length has a measure of 6. What we're going to do is we're going to do the same for each of the givens that we have right here. Draw our taller length as vertical and our shorter one as horizontal with the given information. And then we're going to use the Pythagorean theorem to find the length h for our resulting hypotenuse. And if we need to round, it says round to the nearest tenth. And then we're going to record the length down here. So let's go ahead and get started with this. Let's go ahead and zoom into grid A where they already drew the triangle for us. And maybe over in the margin, what we can do is we can use the Pythagorean theorem with each of our pieces of information. So again, as just a nice reminder, we know our Pythagorean theorem, right, is going to be a squared plus b squared equals c squared, meaning remember a and b are our two legs and c is the hypotenuse. So looking at our resulting information, we are going to have 8 squared plus 6 squared equals c squared. So we have 64 plus 36 equals c squared. That gives us 100 equals c squared. So when we take the square root, we will get 10 equal to c. So we know that this length right here is going to be 10 units. And like the other ones, if you want to go ahead and label them so that way we know this is a length of 8, this is a length of 6. This is nicely shown that this is one of our examples of a Pythagorean triple, having 8, 6, and 10. So let's go ahead and do our next problem together where we might have to do, again, a little bit of work off to the side for Pythagorean theorem, but let's go ahead and draw our triangle. So I'm going to count 8 units up this way for our triangle's longest leg, and then I'm going to make sure I have 4 units this way for the other leg as well. I'm going to go ahead and connect them to create the hypotenuse. And remember, we have a right triangle, just like we did in our previous problem. We didn't necessarily put the right angle there, but it's good to know that. So let's go ahead, use Pythagorean theorem, just like before, where we're going to have 5 squared plus 4 squared equals c squared. So that we have 25 plus 16 equals c squared. So when I add 25 and 16, what do I get? 41 equals c squared. So when I go ahead and do that, I want to take the square root. So I'm going to take the square root of 41. All right, so putting that in our calculator, we kind of get an estimate of our C value. It's going to be around 6.4. So that's what we're going to fill in, is 6.4 units. All right, so we know that that's what that length is, 6.4, whereas we know that our different side lengths as given here, they're going to be 5 units and 4 units. So now's the part of our video where I am actually going to pause right here, and I'm going to have you complete the rest of those 4 triangles on your own. So remember, they give you the lengths of the 2 legs. Try to draw the longest one vertically and see if you can use that and the Pythagorean theorem to find out what the hypotenuse is. Okay, go ahead and pause the video right here, and we'll catch up shortly. All right, let's start going over these. So let's look at grid C. So you can easily see this is a Pythagorean triplet because we get 3, 4, 5, and we should have 5 as our length of our hypotenuse. Moving down to grid D, we can see that we end up getting a hypotenuse of 12.8. Now moving over to grids E and F, we should end up getting 15 as a length for the hypotenuse of grid E and around 6.7 for grid F. Okay, so we did all of this. We're zooming out, looking at this, and we're thinking, what's the purpose behind all this? Why did we do all of this? Well, here's what we're going to do. We're going to look at question number 6 on the next page, and it's going to start to connect these ideas together. So number 6 on the next page says some of the triangles in grids A through F, they're similar to each other. Interesting, huh? So we're going to identify the groups of similar triangles using the grid letter and explain how we know that they're similar. And what we should find is a group of 3 similar triangles and a group of 2 similar triangles. So what I'm going to do is I'm going to zoom out and I'm going to kind of copy and paste what we just did with the triangles kind of over to the left side. You can flip back and forth to look at your pages, but it might be easier for this way. All right, so I have them copied on over in the left side. So let's start seeing if we can notice a pattern, right? So maybe what we could do is see, starting with maybe our grid A, if there's another similar triangle that follows this same pattern, of 6, 8, 10. Remember, we know that similar triangles, it's going to be some type of scale factor that you can multiply to get a bigger or a smaller result. So when I'm starting to look at all the triangles, I kind of notice a pattern with grid C. I see that the length of 6 is cut in half to get 3. The length of 8 is cut in half to get 4, and the length of our hypotenuse 10 is cut in half to get 5. So we're essentially, multiplying by a scale factor of 1/2 to get to that triangle. So I'm going to write down a statement for number 6 that we know grids A and C are going to be similar to each other. So let's start off with showing that the relationship between A and C, and I'm going to write it as a ratio, is going to be grid A's triangle is going to be 2 times more than grid C's triangle. It's going to be 2 to 1. Or if you wanted to have a comparison of 1 to 1/2, that's totally fine as well. Just putting that out there depends on what you want to initially start off with to move to the other. So we have that for A and C. Now, maybe something else that we can start to notice is let's look at grid B and maybe see if it connects to grids A and C or if it connects to another one. So kind of looking at this, we have 4, 5, and 6.4. So look at any of the other grids. Do you see maybe any relationship? Any of the other ones similar? You're right. I'm also starting to notice maybe grid D. So we look at the length of 4, it's doubled here for 8. We look at the length of 5, it's doubled for 10. And ironically, the rounded length of 6.4 doubled is going to be 12.8. So I'm probably also going to make the statement that, let's try the pen, that we're going to say grids D and B, we also see that they're going to be similar. So let's say I go from D to B, right? I could make the similar statement, and I'm just going to zoom out a little bit for us. I can make the similar statement that if we compared D to B, then we know, again, it could be a 2 to 1 relationship. Or like I said before, if we're starting off with D to B, we could say 1 to 1/2. Either way works. I just sometimes like working with whole numbers instead of these decimals that we have right here. So like I said, this is kind of optional to think about. All right, well, we know that there's going to be kind of, a group of 2 similar triangles, but there's also a group of 3 similar triangles. So maybe one of these groups that we found has another contender that we can relate to it. So we've already looked at A, B, C, D. Maybe we could look at grids E and F and see if one of these relates to the other. So start connecting not just A and D, but look at C and B. See which ones have a connection to grid E. All right, so looking at this, we can kind of see that grid E has a relationship with grid C. Do you see how we go from 3 to 9, 4 to 12, 5 to 15? So I would definitely say grid C and E are also similar to each other. So we also know that, if C is similar to A, then we know E has to be similar to A as well, probably with some type of fractional scale factor. So I'm going to add on to the statement that I already kind of have with grids A and C. We're going to add ACE, and we're going to talk about how we can visually see that C and E is going to be some type of relationship. So I'm going to start with C, and we know for every one value of C, we know that of grid E has a tripled amount. So we know we're going to have a 1, 2, 3 relationship there. Alrighty, well, let's keep going on this, and let's look down below and see what we can do and look at for number 7. All right, so let's go ahead and read this part. It says, in any right triangle, the hypotenuse is opposite the right angle. For each acute angle, one of the right triangle's legs is known as that angle's opposite leg. So that's a new vocab word that we're going to be looking at and highlighting. And we know the remaining leg is known as the angle's adjacent leg. So we're looking at these vocab words of opposite, and we're going to really say the one that's kind of across from that angle. So if you want to insert the word across, it's going to be across from the angle. And the remaining leg is going to be adjacent. So if you want to add the word next to, that's what it's really meaning. We're going to use the mathematical words opposite and adjacent in the future, though. So it says in triangle CAR below, we know that our hypotenuse is AC. So that's looking good. It says for the acute angle C, we know that side AR is the opposite leg, right? Because it's across from it. And we know, let's say we're looking at side RC, we know that's going to be the adjacent leg to angle C. Now, let's say we were looking at the acute angle A. Think about which side is the opposite. That's going to be RC. And then think about which side is going to be the adjacent. That's going to be AR. Each time you can see we're not talking about the hypotenuse. We're looking at it in regards to the legs. So something that we can do, maybe add a little bit of color. So in case we're looking at the acute angle C, right? AR is the opposite leg and RC is the adjacent leg. So let's say I was looking at this angle right here. Again, we could mark, it with a tick mark if we wanted to. We know that AR is going to be the opposite leg, and we know that RC is going to be the adjacent leg. Now, let's say we pick a different color. Let's say we pick green, and we're looking at angle A right there. Okay, so let's say we're looking at this angle. It's going to switch. What was the opposite leg for our other angle is now the adjacent one. And what was the adjacent one is now the opposite leg. So kind of interesting to fill that in right there. So keep that information handy because that's going to help with our next problem. So let's look down and look at number 7. So it says in right triangle, BUS. Whew, we're really liking vehicles, aren't we? So it says identify the opposite leg and the adjacent leg for angle U. So I'm going to go ahead and highlight U. I want you to pause the video right here and label the opposite leg and the adjacent leg. All right, let's go ahead and go over this. So we know that the adjacent leg is going to be US, or if you put SU, that's fine. The opposite leg is going to be BS or SU. Sorry, SB. So that's if we're specifically looking at angle U. Let's go ahead and head to the next page. All right, so we are at the part of the lesson where we are going to start looking at our homework. So if you don't have me, Miss Graham, as your teacher, go ahead and check with your teacher on what your homework is going to be. So for my class, it's going to be page, let's try that again. It's going to be page 307, what we're currently on, and it's going to be numbers 10 and 11A. So number 10 and 11A, you don't have to do 11B or C. But the important part is when you're looking at this, all right, for number 11, you're going to have to use scale factor to figure out the unknown side lengths of the different triangles. I definitely want to make sure that you are showing your work here. So please make sure you do that, and we will see you tomorrow.